Welcome back to Lixo Studio software tutorial. In this video, we'll cover the basics about project processing. And around the end, we'll go over coordinate transformation through ground control points and RTK. First, to copy out the data from the scanner, connect it to the computer, and turn on the USB mode. Select the data you want and save it to your local disk. By default, the raw data folder is named after the project start time, but feel free to give it a more reasonable name. Once the raw data is ready, start the software. You can choose to create a new project or open an existing one. Here, I'll create a new project as an example. We recommend creating a project in a local disk with a great amount of free space. And make sure that the free space is larger than 5 times the raw data size. If you are considering doing point cloud enhancement for L2Pro data, or generating panoramic images, then even more free space is needed. Consult our website's frequently asked questions section for more details about space requirements for different upsampling settings. Once the software is started, go to the Processing tab and click Project Processing. Under Project File, select the raw data you would like to process. To double-check whether you have selected the correct folder, click Inside, and you should see Project Data folder and External Data folder. If you are not interested in performing coordinate transformation, then you can untick the ground control point and GNSS boxes. Below, in the coloring settings, coloring using the internal or built-in camera is selected by default, and is the only available option for K1 and L2Pro. If you are using Alta with an Insta360, then select external camera with a Type 3 mount. Later, if you would like to build a mesh model or do panoramic overlay, then tick the Output Panoramic Image box. In the advanced settings, Dynamic Object Removal will remove the moving objects such as cars and pedestrians, and is selected by default. During the scan, if you have performed a start-to-end loop, or whenever the start point and end point is within 1 meter, you can check this start-to-end loop closure box. And then, if you would like to load in the result data automatically after project processing, tick this box. For L2Pro data, there will be an option called Point Cloud Enhancement, which increases the density of the result point cloud data for better visual effects. The distance indicates the distance between the adjacent two points, and thus the smaller this number, the denser the result.loss will be. When this option is selected, the result data will be separated into chunks, and thus cannot be used for mesh function. To perform this function, make sure that your high-performance computer has a large enough disk space. For detailed computer configuration requirements and estimated processing time, consult the Point Cloud Enhancement section on our frequently asked questions page. Finally, Robust Mode option should be left off until advised. You might be asked to enable it as indicated by the PDF report when you encounter certain errors. After you've specified all the settings, hit Start, and the task will begin. You can check the progress by clicking the blue bar below. For the steps of project processing, SLAM mapping and optimization steps will rebuild and refine the point cloud structures. The filtering process denoises and smooths the point cloud. Dynamic object removal erases the moving objects before colorization. And lastly, panoramic images will be generated if specified. If you'd like to do coordinate transformation with ground control points, untick the GNSS box and choose the absolute coordinates file, which records the real coordinates of those points you collected during the scan. This file should have the following structure: point number, which should be the same as your input on the app doing the scan, easting, northing, and height. Once it's loaded, you can click the Edit GCP button to perform a visual check of those points. The left window shows the points recorded by the scanner, while the right window shows all the entries in the absolute coordinates file. Click OK when the points from the two windows match each other, and proceed with other settings as needed. When you have scanned the project with the RTK module installed and connected to your GNSS provider, you can use the RTK data alone to georeference your point cloud. Click on RTK setting to navigate to the RTK setting page. On the window above, it shows the location and number of RTK points available to perform coordinate transformation. Adjusting HDOP, number of satellites, and RTK angle value will influence the number of available points. It is recommended that you proceed with the default numbers for these three fields. For more details on these parameters, refer to the software user manual. Below, under Source Coordinate, choose the coordinate system of the RTK data you received. Under Target Coordinate, choose the coordinate system you would like to reference your point cloud into. Below, these following parameters specify the projected coordinate system information. If you are unsure about these parameters from your project of interest, consult the official EPSG website. For the height fitting box, only tick it when your geoid model is provided in the drop-down list. Other geoid models are currently not supported. At the bottom, these fields are for 7 parameters which are used for transformation between ellipsoids. Whenever the source ellipsoid is different from the target ellipsoid, such as in this case, you would need to provide the 7 parameters. It takes CSV or TXT files, inside which the 7 parameters should be listed in the following order: XYZ translation, XYZ rotation, and scale. Once all the parameters are provided, you can click OK to proceed to other settings. For more details on the RTK settings, refer to the user manual and RTK setting guide document, which could be found on our official website and down in the description below.